All right, what we're going to be looking at today is measures of center. So you've probably worked with a lot of these before. You may not have heard it referred to as this, though. So measures of center, if you think about it, it makes sense. The word center is talking about things in the center or in the middle of a data set. There are three different ways that we can represent the middle of a data set. So we can have the mean, which is the average of a data set. You add up all the numbers in the set, divide it by the number of values. So there's an example right there. You have the median. I think of median like a median in the road. It's in the middle of the row. The most important part is you have to put the data in numerical order, right? If we have Michael Jordan in the middle of our data because we didn't put ourselves in order from shortest to tallest, and he turned out to be the average height because he was in the middle, that wouldn't make sense, right? Important to note, if there's an even amount of data values, there's going to be two middle values. Find the mean of those two middle values. And then the mode is the number that appears the most often. It is possible to have no mode. It's also possible to have more than one mode. All right, let's look at this first example. The data shows the recorded high temperatures for 7 days in Chicago. So first thing I'm going to do is I'm just going to add these up. So for the mean, I'm going to add up 35 plus 0 plus 22 plus 31 plus 17 plus 15 plus 8. I get a total of 128. Divided by, a lot of people want to say 0, oh, that number doesn't matter. Well, it does. It has to be included. It's part of the data set. 0 degrees means something. So for our mean, we're going to divide by 1, 2, 3, 4, 5, 6, 7 values, right? That's how many values it's talking about here. So 128 divided by 7 equals, I'm going to round to the nearest tenth. So 18.28 is about 18.3 for the mean. All right, for the median, we should be putting it in order from least to greatest. So we've got 0, then 8, then 15, 17, 22, 31, 35. I'm going to double check to make sure I have 7. 1, 2, 3, 4, 5, 6, 7. So finding the middle value, I'm just going to cross off. Lowest, highest, lowest, highest, lowest, highest. I'm left with 17 in the middle. That is our median. And the last one, for the mode, which one occurs the most often? We don't have any duplicates here, so there's none or no mode. Okay, so one thing that we're going to add in here is determining the best measure of center. So that means that we want to pick a value of those three, mean, median, or mode, that is the best measure. The reason that you only see mean or median in here is that really more often than not, your mode is not going to be the most common. Because let's look at this first example. If 0 was repeated here, so we had 2 zeros, that would be our mode. Is that anywhere near the center of the data? No. So a lot of times mode isn't really an accurate center, so we're not going to worry about that one. So we're just focusing on the mean or the median. So the mean would be your best measure of center. Oops, sorry. The mean would be your best measure of center if there are no outliers. So for example, if we look over here, there's no values that are way higher or way lower than the rest. So the mean is the best then because it's just going to be a good average. The median is the best measure of center when there are outliers. So in this example, 283 is way higher than the rest. Everything else is 150 or 160. So since 283 is way higher, it's going to bring the average up, and it might even bring your average up higher than every single other data set, which wouldn't really be a good center value. Okay, so for this next example, we're going to find the mean, median, and mode, and then we're going to determine the best measures of center. So, find the measures of center. Mean first. we're going to add these up. And be careful when you're plugging in decimals into the calculator. It's really easy to make mistakes. 58.3 plus 54.5 plus 50.7 plus 60.1 plus 48.7 plus 48.9 plus 9.5 plus 42.2 and 59.2. So we get a total of 432 and 1/10 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9 values. So when we divide that, we get 48.01. I'm just going to leave that as 48 because rounded to the nearest tenth, that's what it would be. So our median, I'm going to put these in order. So let's see, our lowest is going to be 9.5, then 42.2, then 48.7, then 48.9, then 50.7, then 54.5, 58.3, 59.2, and 60.1. So be careful when you're listing out these numbers too, that you're not confusing your decimals for commas or forgetting to put the decimals in, because that's going to mess you up. So we are going to go ahead and cross off lowest, highest, lowest, highest, lowest, highest, lowest, highest. We have one value in the middle. Now remember, if we had circled two numbers in the middle, we're going to add those two together and divide by 2 to find the actual median value. But here, our median value is 50.7. And then looking at this again, do we have anything that repeats? Nope. So there is no mode in this one. So now determining the best measure of center. Basically, I'm looking to see, are there outliers? In this set, 9.5 is for sure an outlier. It's way lower than the rest. So since it has an outlier, our best measure of center with outliers is the median. So our median is the best measure of center, and the reason that it's the best measure of center is there is an outlier. All right, last type of problem is working backwards. So this is something you might do a lot in like high school when you're trying to figure out what type of grade you need to keep an A, or what you need on your final to keep a B, or whatever it might be. So Ryan wants to earn an A in science class. On his last 7 tests, he received an 85, 80, 95, 97, 83, 88, and 97. What percentage does he need to earn on his last test to have an average grade of 90%? So let's just set this up as if we were just calculating it in general. So how do we find the mean? We add these up. So 85 plus 80 plus 95 plus 97 plus 83 plus 89 plus 97. So 1, 2, 3, 4, 5, 6, 7. Plus this unknown test grade. We don't know what it is. To find the average, we would divide this by the number of tests. It's not just 7 tests, because he has this additional test, which means we have 8 tests. 1, 2, 3, 4, 5, 6, 7, plus the unknown is 8. And we want that to equal at least an average of 90. So now we can work backwards on this problem. First, I'm going to simplify to make it easier to work with. So I'm going to add these together. 85 plus 80 plus 95 plus 97 plus 83 plus 89 plus 97. So I get 626 plus our unknown test value divided by 8 tests. We want to equal a value of 90. So working backwards in this, if this value on the side with the variable is being divided by 8, the opposite would be to multiply each side by 8. So we get 626 plus x equals 90 times 8 is 720. Now, the last part, x is adding 626, so the opposite is to subtract 626 from both sides. And we get x equals 94. So he needs to get at least a 94% if he wants to earn an A in science class. Go ahead and work on the homework.